So at this year's WEP, we've had people who are specialists in synthetic biology, computational biology, but you would describe yourself as a microbiologist. How does that differ from the other two? What is microbiology?
I think microbiology was my training as bachelor. To be very broad, microbiology is the study of the microorganisms that live in our planet. But then I will describe more now like applied microbiology, an applied microbiologist, related to biotechnology, because then that means using that knowledge of the microorganisms for the benefit of humankind. To then try to use them, manipulate them, and play with them to get something useful for the people.
And a particular area you specialize in is recombinant collagen?
Yes, synthetic biology in general. Yes, so I'm actually now my PhD is in that the title is synthetic biology, and yes, and I will say recombinant protein production.
Okay.
Yeah, in general, that collagen is just an example. But what I'm learning a lot of production of proteins. Yeah, production of recombinant proteins.
And what is a recombinant protein in this context?
Recombinant refers to the fact that you are producing a protein in an organism that normally doesn't have it.
I see.
For example, collagen in a plant. Plants don't have collagen, but you are taking the genes and putting in a plant as an example. Or yes, all the oldest example that you are taking insulin, which is a human protein, and putting in a bacteria. Which is the first example of recombinant protein production. And nowadays you have many of these type of products in the market and in the research world as well.
And what are the advantages of doing something like that?
Usually when you have let's say for example you need insulin. That's the classical example. Before recombinant technology, you have to take the pancreas of dogs, if I'm not wrong, or pigs, and take the insulin out of that. So imagine to treat a patient how many dogs or pigs you need.
Yeah.
And then it comes usually that comes with some dirtiness. When I mean dirtiness, with some undesired side products that can cause an immune effect on the patient. So that was definitely not the best to do. Doing in a recombinant way allows you to have more control of the production and also higher amounts that you will have if you don't do it in the recombinant way, and also more control in the sense that you can tailor what you want to do. So, for example, going back to the insulin example, what you had before was dog insulin, not human insulin.
Yeah.
And that could have problems in the immune system, which is the main concern. But if you do recombinant, you can take the human gene and put it in another organism, and if you do it well, you get the human protein.
I see, yeah.
Yes, so you don't get something random. You get a human protein that will cause the effect that you want to have.
Okay, and that's already a process that's happening now?
Oh, well, yeah, and again, going back to the example of insulin, now we have diabetic people are getting insulin that is from E. coli. You are getting also now a lot of vaccines that are being produced in bacteria or in some on some other systems, and interferons and many other therapeutic proteins. And now what is hitting the market a lot, it's all these monoclonal antibodies. That are just recently was found a way to produce them in higher yields that are sustainable, economically interesting, and yes. So now, for example, now the new wave, all these monoclonal antibodies that can be used to treat cancer or some other viral infections.
And is it that kind of thing that interests you from a WEP personalized medicine perspective, the ability maybe to tweak those so that they work better with particular patients?
Yeah, so actually that's one trend that you are having now, that you are tailoring the genes, and that's actually the trend in terms of synthetic biology applied to medicine, that you tailor the gene so it works better and you reduce the immune response from your patient. And that means that you need to know the patient and personalize the protein to the person you are treating.
And what first interested you about this area? You were doing something slightly different in your when you studied at KAUST, but it's led you in this direction.
Yeah. So while I was studying here in KAUST, I was more in the area, kind of same thing, but apply in the environmental area. So trying to use microbes and manipulate the microbes, both to clean wastewater, for example, which was actually my master thesis, cleaning wastewater and treating wastewater, or use them to make a better use of wastewater, which was what I was doing with algae here, with the microalgae. That was a very interesting experience, but also I noticed that was a very challenging in terms that industries, or let's put it this way, the money was not there.
Right.
Yes, there was some money, but the money was not there. In terms of bioproduction, the money is in the pharmaceutical part. Let's just face it. And that not only means in terms of job opportunities, but that also means that in terms of research capabilities, in terms of things that you can do, in terms of the standardization of protocols and all of that, it's way more advanced in the biomedicine part. And then you can play more and you can advance more if you are in that area, or in professional terms as well. That's what my feeling. Mm-hmm.
So in some ways, biomedicine and cancer treatment and things like that are seen by industry, at least, as more of a priority at the moment than things like wastewater, because there's more money going into it.
Mm-hmm. Yes, exactly. But because that's a little bit unfortunate to say, but because there are people willing to pay for a cancer treatment and not willing to pay that much to clean our water, which I think is very scary anyway, because both things are very important, and probably at some point even cleaning the water will be more important.
You hope so.
Yes, I do hope so. Yes, I do hope so. Mm-hmm.
So in that move, so you were dealing with algae and wastewater. You took the same sort of techniques, but you also moved physically as well, because you were in KAUST in Saudi Arabia.
Yes,
Where did you go next?
I went back to Colombia afterwards, and now I'm in Australia. Mm-hmm.
Wow! And what's led you there? Which university? What sort of aspect has attracted you to Australia?
Actually, by doing research, I noticed that Australia and the University of Queensland in particular, they have a very top research in biotechnology. In biotechnology is the number 9 in the world, the university I am, University of Queensland. And being there, I noticed why. They really have the process of production of the pharmaceutical part in the structure of the university. So there are different research centers that they are specialized in the different parts of the production, but all of them are connected. And so they have the pipeline. Mm-hmm.
Right.
They have the complete pipeline, and be able to experience that pipeline and absorb what is happening during the pipeline and all the development of these biopharmaceuticals is really, really, really interesting.
And
that attracted me, yes.
It's the Australian Institute of Bioengineering and Nanotechnology?
Right, correct.
So does that mean you're being exposed to interesting research about nanotechnology as well that informs things?
Mm-hmm.
How has that affected your research so far? Or how would you like it to, do you think?
Yeah, well, just to put an example, one professor in the center has already developed a hydrogel that has similar elastic properties as the skin, So in terms of just to put that in my research, it will be very good to apply that type of nanotechnology and material development combined with these recombinant proteins to make the real product that will come afterwards for the treatment of the wound. And in the center there are different people working with different types of materials that could be applied for medicine. There are other people, I don't work with that. There are other people working in delivery of drugs for the treatment of different compounds, and they come with really crazy ideas and like, oh my god. And even if that's not related to me, absorbing that, the logic that is behind that, and that way of thinking, that is also very helpful for your own research.
And we've talked about how you've been in Saudi Arabia, you're from Colombia, you've gone to Australia. When you come back to KAUST, because you're an alumnus, do students ask you about how to move between those countries like that? You know, adjusting to a new country. Is that something you struggled with at all?
I haven't met that many students that have asked me. I mean, I have met other like people here in the compound, but yes, I think as I say, if you decide to come here, it's because you are ready to change, and then I think people that are here are ready to move afterwards to anywhere. So and I think that's why they haven't asked you like, how do you think it will be now in the new place. What I have said, and I said in the presentation also, is like it's what is hard is to move back outside to how the world works outside of KAUST. That is way more challenging rather than changing country or changing new culture, which is kind of okay, like going back to the dynamics of the real world. Real world. That's what is challenging, and that's what I say to the other students, like, get prepared. When you go out of here, you have to be ready to a world that is actually very competitive, that is a world that is asking for you the maximum all the time, a world in which there is unemployment, a world in which there are bad contracts, a world in which you can be unemployed for 1 year looking for something, and meantime you have to keep paying your bills. It's more that part, what I would say today.
And that you've had that from your own personal experience, that sort of struggle, those challenges?
After leaving KAUST and going back to Colombia, yes, actually, there was let's say a kind of complicated period in which I didn't get good jobs. I was getting like short contracts, bad payment, and yes, well, that's part of the challenges of Latin America in general.
But your field, at least, is there's more and more developments happening all the time in synthetic and biology and those sorts of things.
Well, yes, and the field has changed substantially now. Now being in Australia, I noticed that the field has changed quite a lot from when I was here in KAUST. And I think also I think KAUST, we don't have that much of synthetic biology compared to other institutions, and I think that's a part that we can work here a lot. And at least in Australia, then you notice, yes, oh wow, there are many things happening. The field has changed a lot. Probably one of the main changes in that sense is now we can make synthetic DNA. That was something that we couldn't do 10 years ago. 10 years ago, we can only make short strings of DNA, and now we can make an entire plasmid, an entire big molecule of DNA, synthetic, completely synthetic. And I'm like, wow, that's crazy. Because that means, and that's what is synthetic. One part of synthetic biology dealing with now, that you can make proteins that never exist before. Really crazy proteins, like, okay, I want to make this protein that I think is gonna behave like this and this and this, and you just make it something completely new that nature hasn't invented before, and see what happens.
So that sounds fascinating. But what would have got you interested before all of that was possible? What got you interested, maybe as a child or as a young undergraduate, in this whole area?
Oh my God! Well, I think that's a long answer to make it short. When I was in the school, we have a opportunity to be in classes in universities. So when we were in like the last 2 years of high school, they say, okay, you can go to one university and take one class.
Wow.
And for different reasons, I ended up, or not different reasons, I say like it could be interesting. I ended up taking genetics in the university I did my undergrad later on. And I was like, wow, this is, I mean, when you are coming from a school in which things are probably, they don't move that fast,
No.
and you are more like following the protocols of the school, and then you go to university in which they put you a lot of knowledge in 1 hour. It's like, I was like, oh wow, this is so great, this is amazing. And I think that's actually how the journey started. On the way, they were like, okay, well, I like more bacteria, I like more microorganisms, so I want to learn more about microorganisms. And then later, like, the realization that, actually, these guys can do many things for people. Well, let's continue on that way because I want to have impact on people. I just don't want to have knowledge. I want to do something useful for people. So let's go in the field of biotechnology. And then that was just more recent, like, okay, and now we can do these things with the proteins and with the DNA, with the synthetic DNA. So let's go in that way and see what happens.
And final question:
No.
what is it that you see coming in your field in the future that you think is the most exciting, say in the next 2, 3, 5 years?
Well, there are many things. There are many things. I think there have been good improvements in terms of the production, and I think that's one big part in which the field is gonna move. Trying to optimize production. So we already have some systems that are producing some established proteins, but still there is a big room for improvement, and I think industry is pushing a lot to make improvements in that direction. That's more like from an industrial point of view. Probably from a scientific point of view, I think the entire field is moving towards this thing that I find fascinating, to make fake organisms, to make organisms from nothing.
Wow.
And that goes back to the very fundamental question of what is life. Yes, and I think that's really, really fascinating because that's a question that doesn't have an easy answer. That many things come behind that, and you can even think from philosophical points of view, like, okay, what is life, and that you have this field really challenging the question. Wow, that's like, oh wow, like what would be the answer? Like, oh my god, and this thing that I want to be part of the answer. Like, I want to be there when that happens. When they finally, I don't know, make these completely new organisms that never exist in nature. And they're like, oh my god, are we? And all these questions, like, we're really playing to be God, like making an organism that never existed before. Like, oh yeah, with these proteins that never existed before. Like, are we playing with life, and how it impacts you? Because at the end, you are also an organism. Yes, and then, yes, I find that part really, really exciting.
Great. Thank you so much for your time.
No, thank you so much for the opportunity, to talk here in that is very. And I was saying also in the interview on the interview that we're making, I think it's really fascinating to come back here and after such long time and be kind of able to close a loop, like close a circle. And I don't know, it's like coming back to the town part of you grew up. It's really, really wow, like many feelings, many nice feelings.
Great.
Coming back here.
Thank you so much.
No, thank you so much.
Thanks.